In this example, I'll use the law of cosines to help us find an angle in a triangle where we know all of the sides, but none of the angles. So here's our triangle, and what I'm going to do is I'm going to start by finding angle A. So we're going to be looking for this angle here. So since I decided to look for angle A, I'm going to write the cosine version that has lowercase a squared all by itself. So this is lowercase a because it's opposite from angle A. This is lowercase b, the 73, and 47 is lowercase c because it's opposite from angle C. So let's start off and write our law of cosines. So first I'm just going to write it with the variables in place so I don't make any silly mistakes like do a plus instead of a minus. So a squared equals b squared plus c squared minus 2bc times the cosine of a. That's a good looking c right there. All right, so let's fill in what we know. A squared. I know a is 32, so 32 squared equals b is 73 squared plus c is 47 squared minus 2 times 73 times 47 times the cosine of a. So when we do this, it's important to remember that this part, the 2 times 73 times 47, is something that we're multiplying by the cosine of a. It's attached to it with multiplication right here. So we're not going to do this and then subtract. We have to do something different to get this by itself. So let's start by doing all of the multiplying. So let's see, 32 squared, that's 1,024. 73 squared is 5,329, according to my calculator. 47 squared is 2,209 minus 2 times 73 times 47 is 6,862 times the cosine of a. Now when we're doing this, we're going to want to get the cosine of a, this part right here. We want to get that by itself. So kind of think of that as if that were one big old x. If I were trying to get that by itself, I'd want to get rid of this and get rid of this first, and then I'm going to divide both sides by this guy right there. So let's do that. So to get rid of the 5,329, I'm going to subtract that from both sides. So we're going to have 1024 minus 5,329. I'm going to take away the 229 also, or 2209 I mean. That's equal to negative 6,862 cosine of a. So let's do this subtraction over here. When we do, we will find we have negative 6,514 equals negative 6,862 times the cosine of a. Now this is multiplied right here. So to undo that, we're going to divide both sides by negative 6,862. When we do, we'll find on our calculator that tells me it's about 0.94285. That's equal to the cosine of a. So now I don't want to know what the cosine of a is. I want to know what a is. So to sort of undo the cosine of a, we do the inverse cosine. So we're going to do the inverse cosine. That's with the negative 1. Now this is a place where you're going to want to use the previous answer key on your calculator so that you don't type this in, because this is not the whole part of my answer that I got when I did this division. So we're going to do the inverse cosine of 0.94285, and that's going to be equal to the inverse cosine of the cosine of A. Well, the inverse cosine and the cosine cancel each other out. They're inverses. And so when we do this, we will get for our angle A, that A is equal to 18.3254-ish degrees. So that's about 18 degrees. I think it's fair to round it off to that. Now that I have an angle, if I wanted to solve the rest of this triangle, I would use the law of sines to find the other angles, because that is a little bit simpler and not as algebra intensive, because we're just solving a proportion. So this is using the law of cosines in a triangle where we know all of the sides but none of the angles to get one of the angles. Next, I'll show you how you can finish this by using the law of sines to find the other two angles. Thanks for watching. Have a mathy day.